In this video, we will be going over a past paper question for GCSE Maths higher tier. The diagram shows a circle, radius r centimeters, and two regular hexagons. By considering perimeters, show that 3 is less than pi, which is less than 2 root 3. So in this question, we have geometry mixed with some sort of inequality here. So we're going to be having to compare perimeters. So we can immediately ascertain that we need to find the perimeters of both of the hexagons and of the circle and compare them to get our inequality shown below. So the first thing that we're going to do is we're going to attempt to find the perimeter of the inner hexagon. So here is the inner hexagon highlighted, and as you can also see in the diagram that we have drawn, we have drawn the center of our shape, and we have drawn two radii of the circle. So with this, a known property of a regular hexagon is that it can be divided into 6 equilateral triangles. One of these triangles has been shown in the diagram. So using this, we can find that one of the sides of the hexagon is equal to r, because as we know, all the sides on an equilateral triangle have the same length. And so our radius is equal to the length of one of the sides of our smaller hexagon. Since we know the length of one of the sides, we can find the perimeter of the whole hexagon. For this, we can do 6 times r. And so that just can be brought together to give us 6r. And here we have the perimeter of our inner hexagon. Now we're going to move on to the circumference of our circle. Now this step is quite easy because we know the equation for the circumference of a circle. And this is 2 pi r, where r is our radius. Since we have the length of r already as r, we don't have to change much in this equation, and we can just have our circumference with the equation of 2 pi r, and we can keep it like that. Next, we will move on to the outer hexagon. Now this one is a bit harder because, as you can see by the diagram on the left, when we do draw an equilateral triangle, it doesn't really fall within the bounds of our circle, so we can't use any r values immediately. However, we can see that we can form 2 right angle triangles from our equilateral triangle by splitting it in half. So as we're shown in the question, the length of all of the sides of the larger hexagon act as tangents to the circle. And something else that you would have learned in circle theorems is that the tangent and the radius meet each other at 90 degrees. They are always perpendicular. So this allows us to get our 2 right angle triangles, and from here we can use SOHCAHTOA to find the length x that we've attributed here to half of one side and so at the top of our triangle we know that all the angles in an equilateral triangle are 60, and we have split one of these angles in half, which gives us 30. So now we can use tan, and for that we know that tan theta is equal to opposite over adjacent. And if we substitute our values in, we get tan of 30 is equal to our opposite, which is x, over our adjacent, which is r. And so we have to rearrange this to give x in terms of r, because that is what we're using here. So by rearranging, we can get x is equal to r times tan 30. And so using our trig identities, our known trig values, we know that tan 30 is equal to root 3 over 3. And so this is what we're given x as. X is equal to r times root 3 over 3. Now, we have to get that one section into the whole perimeter of our hexagon. So our value of x is just half of one of the sides. So we have to multiply our value of x by 2 to get the length of one side. This is quite simple. So 2x is just equal to 2 times r times root 3 over 3. Now this is just the length of one side, and now we have to find the length for all 6 sides. So following on to that, we just have to find the perimeter of the larger hexagon is equal to 6 times 2 times r times root 3 over 3. Now here we can cancel out our 3 in our denominator with our 6, and we can get 2 because 3 times 2 is 6. And we're left with this simplified form for our perimeter as 4r root 3. Now this is our perimeter for our larger hexagon, but from the initial question, we still have to form our inequality using these perimeters. So, as we know, the perimeter of our smaller hexagon is smaller than the circumference of our circle. And we know the circumference of our circle is smaller than the perimeter of the larger hexagon, or the outer hexagon. This is shown clearly by the diagram. So now what we have to do is we have to build an inequality out of this. The perimeter of our inner hexagon, as we know, is 6r. The circumference of our circle is 2 pi r. And the perimeter of our outer hexagon is 4r root 3. Now, we need to go back and see what form we need it in. Because what we have now is not 3 is less than pi is less than 2 root 3. So we know that this is what we're aiming for. So now we have to find a way of simplifying our current inequality to that. So one of the first things we can do is we can factorize out r and divide everything by r. So here we're left with 6 is less than 2 pi, which is less than 4 root 3. And now we have to simplify further because we still don't have what we want. So what we can do here is we can now divide everything by 2. So here we're left with 3 is less than pi, which is less than 2 root 3. And this is the inequality that we've had to obtain, that the question asked us to obtain, and here we have it. So with questions like this, you want to see what your end goal is, and here the question has really helped us because it said to use the perimeters to compare it. If you ever feel stuck, just always think about how you can work backwards from the answer that you're given in show that questions. This can be really helpful when you're doing your exams. As always, thank you for watching and make sure you subscribe so you don't miss out on any new content.